Hello, and welcome to Living on the Edge, Deploying and Protecting Modern VMs on OpenShift. Today's webinar is sponsored by Veeam and Red Hat and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech, and I'm delighted to be your moderator for this special event. Now, before we get to today's great session, we do have a few housekeeping items that are going to help you get the most out of it. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. So not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh will fix most audio, video, or slide advancement issues. But if that doesn't work, just let us know there in the Q&A and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we're offering several resources, and I'd especially like to call your attention to links there. One is to data protection for OpenShift Virtualization with Kasten by Veeam, and there's one on, it's a virtualization reference architecture for Kasten and OpenShift. I encourage you to access those resources now and feel free to share them with your friends and colleagues. Now, third, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for that prize. The official terms and conditions of today's prize drawing can also be found in your handout section. Just scroll to the bottom and you'll find a link with the details there. Now, one last bit of housekeeping. One of the best benefits of this event is the opportunity to ask a question of our expert presenters. So to help encourage those questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. So after the event is over, we'll look at all the questions that came in and the ATM team will pick out the very best one, contact that prize winner. Okay, with all that housekeeping out of the way, let's get to today's fantastic session. So it's my pleasure to introduce you to our presenters today. We have Matt Bader. He's from Veeam. He's a principal for Kubernetes and native solutions. And we've got Martin Jackson for Red Hat. He's a senior principal software engineer. Matt, Martin, welcome, gentlemen. Thanks for coming on.
Happy to be here, Scott.
Yeah, thanks for having us.
And I'm realizing, looking at that last slide too, that I probably need a newer picture for these things.
Yeah, there's a lot of mustache that wasn't in the photograph.
Yeah, maybe catch people off guard. Oh well.
Before we get started, just to kind of level set as much for you guys, Matt and Martin, as for the audience, we have a question for everybody just to kind of see where people are. This first one is, are you evaluating alternate hypervisors, including KubeVirt, for running VMs in your environment? And there's the, yes, no, and several flavors of no to get into the nuance. So we'll just leave that up here just for a second for everybody to have an opportunity to answer that. But Matt, while we leave this question up, maybe you could tell us a little bit about yourself and maybe about what's on the wall there behind you. Just interesting.
Yeah, sure, Scott. So I'm a solution architect that's part of our Veeam Kasten product team, which is focused on Kubernetes data protection, right? But we're talking about VMs, which a departure maybe from normal Kubernetes data protection talk tracks. We'll try and bring that together today. But virtualization has been, like I'm sure many of the people on the call, the foundation of my entire career. I can still remember seeing my first vMotion all the way back in 2006, maybe that was, and what an aha, like, oh, things are going to change moment that was, and how much things have changed in the last nearly 20 years, but like still coming back to virtualization as this like foundational part of everything we do. But yeah, so behind me, I suppose hard to ignore my problem. I can quit anytime I want of buying bicycles, or in this case in my office, it's a lot of just bike frames. I enjoy, they're art to me. I like looking at them.
Is that a Greenland kayak paddle as well back there next to the door?
That's actually a prop, a propeller for what was basically modeled after some of the early Wright brothers designs. In the same way that I am a cycling nerd, my wife is an aviation nerd, and we ran out of places to put various items. So that's migrated in here.
That's awesome. And last thing, before we go to the next poll, looks like we've got a lot of people, like 30% yes, looking to evaluate, and another almost 25% are looking in the next 6 months. So a good chunk of folks are looking there. So
maybe we'll change some minds for the other half, not quite half of you in the other bucket.
Sounds good. All right, and let me bring up the next poll. This one is, how are you protecting your Kubernetes environments today? We're all stateless, already using Veeam Kasten, OADP, Valero, another commercial backup tool, and homegrown scripts. And while we give everybody an opportunity to take a look at that one, Martin, can you tell us a little bit about yourself and maybe also your cat collection?
Yeah, sure. I'm a software engineer at Red Hat. I've been at Red Hat for just a little bit over 3 years. And one of my main areas of interest and responsibility at Red Hat is with the validated patterns framework. Now, before I worked at Red Hat, I had a long career at at a customer. So a long enough career that I'm technically considered a retiree of that company. So, that's kind of cool. I got the lifetime discount card. But as far as my cat collection goes, I have 6 cats at the house. We like to say that it is a redundant array of inexpensive cats, and they are both striped and mirrored.
Are they really inexpensive though? Is there such a thing as an inexpensive pet? Goldfish, maybe?
Acquisition cost low. Maintenance cost relatively high.
Yeah.
Excellent. Well, with that, I'm going to leave it to you guys, and I'll pop back up for the Q&A when we're toward the end here.
Awesome, thank you. And good, interesting breakdown on. Thank you for the responses on how folks are protecting their environments today. I think that's good feedback as we jump into today's topic. So, all about protecting, this new category that we call modern virtualization or modern VMs, essentially leveraging the KubeVirt technology to run virtual machines on an OpenShift cluster. So we'll dive into a little bit of the why that's given this project life. We'll talk about how Kasten addresses that as a use case somewhat differently than other Kubernetes native applications, and then really what we want to get to is doing this at scale, doing this in a very repeatable way, and that's where we're going to introduce the Red Hat validated pattern, and then we've actually got a deployed environment we can jump into. And show you folks, what an example deployed pattern for leveraging Kasten and OpenShift virtualization looks like. Hopefully, we'll get some interesting questions out of that, and can be kind of flexible about what we look at. So, with that said, I'll touch briefly on the topic of why do we even need data protection for Kubernetes in the first place. I saw a number of you respond in the previous poll that, hey, our applications are entirely stateless. I would argue that stateless applications don't necessarily exist. That state might exist outside of the Kubernetes cluster, in which case there might still be value in having an orchestrated backup of all of those components that make up maybe the stateless front end and business logic that you might be running in Kubernetes, and maybe some of those external data services. But what we're seeing more and more of is this growth of running data services directly on Kubernetes itself, being able to take advantage of this abstraction layer of a solution like OpenShift, where I can run OpenShift on premises, I can run it in AWS, in any hyperscaler of my choice, but still have true portability of my workloads at that point. So obviously, as soon as we're talking about persistent data being consumed in a cluster, we have to talk about how that's then protected. Why does it need to be protected? I think everyone saw in that opening actual tech reel about learning everything you can about ransomware. That boogeyman very much exists in the cloud native world as well. This is an ever-present challenge. But it's also the idea that I can't leverage my traditional tools that I might use for doing, say, vSphere backups or AWS EC2 VM backups to be able to address my Kubernetes applications. I need something that natively talks to that platform. And that's exactly what Kasten itself was built for. And we'll take a bit closer look at that in another slide or two. But we're not really here today to talk about digital transformation and cloud native applications. What we really want to talk about as a workload is this idea of modern VMs. So if I think about traditional quote unquote traditional infrastructure, a virtual machine is a very infrastructure centric workload, right? Regardless of what that underlying guest is, sort of the primitives and capabilities exposed to it from the hypervisor are really the same, regardless of what that the guest operating system might be. Whereas on the right hand side, if we think about cloud native applications, 11, 12 factor applications, the application itself is sort of tightly interwoven with the infrastructure. Kubernetes is famously, very, very customizable and extensible, which creates opportunities and challenges both. Everyone that knows me on a personal level knows I'm like a broken record with the phrase, the good news is you have options, the bad news is you have options. Martin has heard this out of my mouth 2 or 3 times just in the last 30 minutes while we were getting ready to run the webinar. So when we think about true cloud native applications, whether they're using different CNIs with different capabilities for networking, or using various other solutions that are bringing custom resources into the cluster, again, it is a much more application centric workload. In the middle of this, the workload that we want to talk about today is OpenShift virtualization. It's the idea of running VMs on a Kubernetes cluster. I'm happy to get into some of the high level reasons as to why. Martin, I'm not sure if you've got anything that you'd like to contribute on this front of why Red Hat is seeing interest in folks wanting to adopt OpenShift virtualization.
Well, sure. A lot of what you've seen from Red Hat in the last few years has been focused around what we call the hybrid cloud story. And that's the idea that you want to be able to run your applications, because no one runs infrastructure just for the fun of running infrastructure, except for, a few home labbers. But there's not much of a market in marketing just to home labbers. Large companies that have business interests operate infrastructure because they have applications that they need to run. And they want to have as much flexibility and power to run those applications as possible. And the way that one way to achieve that goal is to have a common layer of infrastructure that you can, or a common infrastructure abstraction that you can use across different infrastructure providers, whether that be on a hyperscaler or 2 hyperscalers, bare metal or some other way of doing it. And OpenShift is much more than just a distribution of Kubernetes. It is that abstraction that allows you to express what you need from your applications in, yes, a Kubernetes native and Kubernetes compliant way, but also across your on-premises infrastructure or whatever hyperscaler you choose to run in. And since a lot of companies have large investments in applications, you have these sets of applications that in some cases are quite old, but still need to be supported. And what do you want to do? What are you going to do if you want to run on Kubernetes, but your application is not ready to be Kubernetes native? Well, one very compelling option for that is to run it in a virtual machine. But if your virtual machine infrastructure doesn't speak Kubernetes, what do you do in a Kubernetes-centric, Kubernetes-native world? You could be stuck there. So OpenShift provides OpenShift Virtualization, which gives you a Kubernetes-native way of running and orchestrating your VMs so that you can have more options open to you as you make these transitions for lifecycle from the traditional way of doing things to the cloud native, cloud first way that we're seeing become more and more common.
Well said. Yeah, it really, it provides kind of a best of both worlds scenario where you can adopt sort of one top level management stack for everything, but don't have to re-platform every application under the sun to take advantage of OpenShift otherwise. And that's not a realistic outcome for a lot of organizations. There are some apps that simply can never be, might be a stretch. Anything is possible, right? With enough time and money, maybe.
Time, money, and risk, but the question is, is that the best use of your time? Is that the best use of your money? And is that the right risk profile that you want?
Great point. So hopefully that addresses somewhat of the why behind, again, this look for, there's maybe other motivations at this point in time to consider alternate hypervisor solutions that we don't need to get into discussing necessarily, but this is a rapidly evolving space that we are seeing quite a bit of interest around, and again, I think just having that consolidated management paradigm is a really tempting proposition for a lot of organizations. But there are other challenges to solve there, and Red Hat has done an incredible job of this unto themselves. Whether it's in terms of your basic VM management capabilities and software-defined networking capabilities, the migration toolkit for OpenShift virtualization to make it really easy to move workloads over from existing deployments of things like vSphere. But one of the other big gaps in that story is, going back to that, why do I need data protection in Kubernetes in the first place if all I'm running is stateless workloads? Virtual machines are inherently stateful workloads, right? So and I apologize for jumping into what otherwise looks like quite an eye chart to begin with. But if I look at my little key down here on the bottom left-hand side, I see one little green icon that's maybe representative of just a normal cloud native application that's comprised of things like deployments and stateful sets and config maps, secrets, other custom resources, and then also persistent volume claims that are the representation of the actual underlying storage that's being provided to these applications. A virtual machine is really no different than any of these applications. It is basically an encapsulation of KVM processes that would be used on a traditional bare metal deployment of KVM to run, isolated virtual machines on that host. And I think that's something that sometimes people hear OpenShift virtualization and think, oh, this is a very new thing. But this is based on, really tried and true technology that we see deployed across every major hyperscaler today. It's just, again, a different means of looking at it from a management perspective. And this is, specifically where Kasten comes in for any Kubernetes native workload. I need ultimately a solution. We can see the little green Kubernetes icon in the middle of that worker node diagram on my second worker node. So Kasten itself is just another Kubernetes application that is deployed to my cluster, and importantly has the ability to talk natively to the Kubernetes API server and a variety of underlying storage. So the idea here being I need to communicate with the API server to figure out what are all of the resources, whether you call it metadata or the manifests, associated with a given workload. So these are all of my config maps and secrets and other custom resources that might also be associated with my virtual machine. And then also to be able to interface with that underlying storage, whether that's, again, through the Kubernetes API service in some instances. In others, we actually have direct integrations with a variety of storage providers. But specifically for the purpose of being able to orchestrate snapshots and orchestrate the export of that VM data off of the cluster. That's really key in this scenario, is that creating snapshots of a virtual machine is not the same thing as backup. Snapshots are never the same thing as backup. The goal here is to create, durable copies of these workloads at a point in time, such that, whether it's something malicious like ransomware or the everyday, oops, I removed this thing that I didn't mean to, and we need to get it back. These are sort of the core basic reasons why we need data protection for any stateful workload. So why not then just leverage a quote unquote free option for doing data protection of something like an OpenShift virtualization VM? Valero is a project that exists. OADP is a project that's based on Valero. That these are potential options that I might consider if I'm looking at adopting a solution like OpenShift virtualization. I will compare this to Martin's acquisition cost of the cats. If a relative gives me a free cat, or what I normally call the free puppy fallacy. It's funny that we're literally dog versus cat people. There are a number of other considerations as to whether or not that's going to marry with my use case. So some of the big ones that we can discuss at a high level here is the cost of operationalizing a solution. So Kasten is something that focuses on ease of use, being able to deliver sort of a full UI for operations for end users, complete with monitoring, alerting, all of the sort of enterprise bells and whistles that someone would need to plug into the rest of their environment. This is something that you would have to consider. All right, how do we build that ourselves if we're going the free puppy route? Another important consideration we see, again, relevant to ransomware in particular, is Kasten fully supports creating immutable backups to a number of different a number of different targets, whether that be AWS S3, Azure, GCP, other S3 compatible object stores that support the object lock standard, versus, again, on the open source side today, no support for immutability. Again, meaning that if someone has access to that data, they could wipe out all of my available backup data. When this is potentially your last line of defense against something like a ransomware attack, immutability controls to me become table stakes, right? We won't get too deep into the encryption nuances of Kasten versus Velero, but at a very high level, this is, to me, one of the biggest security challenges in that project today. Is that every backup is signed with a common known key. So in the same way that, okay, I don't have the immutability controls to prevent against someone deleting it, also means if someone has access to that bucket, they'd be able to decrypt what that backup data actually is. It's like having the same lock to your front door as everyone in the entire town. Is your front door actually locked? I don't think so. Versus on the Kasten side, having sort of per policy, per application in encryption controls. So even if someone does have direct access to that bucket, now I know they can't, delete or manipulate that data. They also can't see what is actually in that backup data. And then I think one of the last sort of big differentiators between the free puppy and Kasten here is the idea of being able to perform secure self-service operations in Kasten. So as an application owner, or thinking about for the KubeVirt use case, you could have admins that are only responsible for some group of virtual machines on a larger shared cluster. Velero is very much a tool that was built for single cluster admins, someone that has the keys to the castle. Whereas we're trying to enable a world where I can provide very tightly RBAC namespaced access to say, okay, this user can do self-service restores for this group of virtual machines in these namespaces, but not these other namespaces. So again, there are alternatives in this space, but I think the further you dive into your actual business requirements, having an enterprise ready solution like Kasten plays a big role, and we see this reflected in the types of customers that are adopting Kasten today. So this particular reference fits right into our topic of deploying virtual machines, specifically deploying virtual machines to the edge. So the U.S. Navy is both a Kasten and Red Hat customer deploying OpenShift virtualization on naval ships. You probably don't get much more edge than that, I suppose. But even within that ship, if I've got essentially availability zones at the fore and aft of a ship, I need to be creating backups that can be moved to that other cluster and potentially then exported off of the ship entirely as connectivity allows. But in doing this, it's not a one-time operation, right? Of setting up all of this. There's definitely whether it's in the edge or anywhere in the data center. I think because Kubernetes itself is very declarative to deploy in the first place, seeing a trend of people adopting clusters for very specific use cases versus having just like one massive production cluster, one massive test cluster, one massive development cluster. So having an ability to, automate the rollout of these things, and again, doing so in a consistent way, is incredibly important. This is something in the Kubernetes world. GitOps is becoming, a preferred method for doing this kind of change management. And that's where we kind of find ourselves talking about the Red Hat validated pattern framework. And I don't want to steal any thunder from Martin here before I conversationally go off the deep end.
Yeah, thanks, Matt. The validated pattern framework is something that Red Hat started development on a little over 3 years ago. And the idea is that in the technology industry, we've had reference architectures forever. And a reference architecture is a nice document. In the old days, it was on paper. Nowadays, you get them in PDF and in PowerPoint, and they have loving descriptions of all the different technology components and, how, this wonderful solution is put together. But we thought, hey, wouldn't it be cool if, because we can do this with GitOps, instead of delivering the reference architecture as a paper document, which is relatively static, how about we deliver it as a repository, as a self-describing software artifact that people can try out and experiment with and extend on their own. And that is fundamentally what we think of the validated pattern framework as delivering. It's a mechanism for developing GitOps solutions, primarily in Kubernetes, but we also believe that GitOps extends to non-Kubernetes objects, and this particular pattern is a good example of how we think that works. And we believe that being able to deliver these GitOps solutions has a lot of benefits for a lot of different constituencies. But the key aspects of them is that, first of all, a validated pattern is a configuration as code repository. It is a complete soup to nuts, blank cluster to fully functional use case implementation of some interesting use case concept. In this case, it's backing up OpenShift Virtualization VMs with Veeam Kasten. Within the pattern framework, there are different tiers of support. The highest tiered patterns are actually maintained by Red Hat engineers, and the particular pattern that this particular Veeam Kasten pattern is based on is one that I'm responsible for maintaining. And there is a team at Red Hat which is responsible for maintaining these different patterns, so that if I get hit by a bus, then there are other people at Red Hat who can maintain this pattern. But the idea is that by delivering so many pre-configured, pre-validated, pre-tested components, it should accelerate your experience in moving from proof of concept to production, because much of the variability of, do I do this or do that? As Matt said, the good thing is that you have options. The bad thing is that you have options. Are we doing 2x8 VMs? Are we doing 1x4 VMs? How big is the disk? All of these things are aspects that you have to work out in the POC phase. And one of the benefits of having a POC like that's shipped in this validated pattern format is that you can install it as given and then take it and customize it to your heart's content, knowing that within that framework, the things that you don't change are going to reliably function as you receive them. And so this helps build confidence for the user in that what you're seeing has been tested. And one of the key aspects of the validated patterns that we maintain as Red Hat is that we do ongoing CI/CD of all of these patterns. Each of the tested and maintained patterns are the tested patterns are tested at least monthly. The maintained patterns are tested at least weekly. And so we're watching those CI/CD results as new OpenShift versions come out, as new aspects of the components come out. In this particular case, we've got OCP itself, which is OpenShift. We've got OpenShift Virtualization. We've got OpenShift Data Foundation, or ODF. We've got Ansible Automation Platform. And if all of these products have their own life cycle, and they're releasing new versions all the time. And so by testing all of these things as an integrated whole, we can also catch any potential regressions that happen within this stack. And we don't publicly report on all of the bugs that we find in, say ODF and container native virtualization, but I've got my list, and I can tell you that list is non-zero.
It is a great benefit when you think about how many components, even the simplest deployments these days, how many individual components you're integrating there. And I'm sure that most everyone on this audience that's been a practitioner, been an administrator, has run into issues where, yep, I've taken the reference architecture, the solution guide PDF or printout, which was outdated the moment it came off the printer, and by the time they got through to step 504, that this is broken. This does not act the same way that it did with the versions that were created in here, and it's a tremendous benefit when we're talking about integrating so many parts.
Yeah, because whoever's paying you is not paying you to just mess around with Kubernetes. They're expecting value and benefit at the end of the day, and we want to accelerate your path to that value and benefit as much as humanly possible, while still providing you the freedom to be able to customize and do things the way you want to and need to do them.
And if someone is paying you to just fool around with Kubernetes, like don't tell anyone, just enjoy it. That sounds like a lot of fun.
It really does.
So, sorry, I'm jumping there. I know that we've probably got some folks coming from the traditional virtualization Veeam side of things in the audience. Martin, do you want to just touch on quickly these sort of principles of GitOps, how this is somewhat different, I suppose, than doing traditional configuration management?
Yeah. And to be clear, GitOps is something that really grew out of traditional configuration management. As we did traditional configuration management, we realized that there were lots of good things about the way that traditional configuration management was done that would be really good to bring forward and highlight in this new world of Kubernetes. Kubernetes itself, in many ways, came out of the traditional school of configuration management that said, everything should be declarative. And a declarative thing is one where you focus on the end result, not as much on the steps that you take to get to the end result. So you define the state that you want a system to be in, and then you trust the underlying system to take the steps necessary to achieve that state. As a practical matter in Kubernetes, you give Kubernetes a bunch of manifests, and then you trust that the cluster will get into the state that you've declared that you want it to be in by use of those manifests. And that's the way that GitOps works in Kubernetes. That you have these manifests which you nicely keep track of in Git in version control, and so you always know exactly what you're deploying, and you always know exactly what the goal is that you're trying to get to. By storing them in Git, that makes them versioned and immutable. So any particular commit in a Git tree should represent a different state of the Git repository that you're defining. So if you want to change the number of VMs that you're deploying, you commit that change to Git, and that's the number of new VMs that you're deploying, or that's the new size of the underlying storage. Depending on the different Git commit that you make. There are lots of different potential examples, but once you get used to operating this way, it's really exciting, and it's really wonderful to watch the machinery, kind of take the instructions that you've given it and make it work out that way. And that's the responsibility not only of the GitOps agents, like Argo CD or the OpenShift GitOps operator, it's also the responsibility of the various operators within the Kubernetes cluster to see the changes and to work through the state from the previous state that you'd said you wanted for it to the ultimate state that you're saying you want. The third principle in GitOps is that it's pulled automatically. You don't want to have to go and tell the cluster every time, hey, I want to change, I want to change, I want to change. The cluster should itself recognize that the Git repository has changed and should be in the process of moving from one state to another state. And so this is fairly easy to achieve by simply watching the repository and looking for new commits. And finally, continuously reconciled. What that means is that when there is a change, it is the responsibility of the GitOps tooling to see that the change has been made and to start the process of initiating the steps necessary to make that change. So the manifests change, and those manifests are then applied to the Kubernetes API, and that will result in more VMs being deployed, less VMs being deployed, memory being increased on VMs, memory being decreased on VMs, whatever you mean. But basically, when you say something in Git, you expect that that whatever changes in Git, those changes are going to be represented on your cluster or clusters. And when taken as a whole, when you're used to deploying things in this way, this makes your deploys and the repeatability of the things that you're doing in your deployments go up dramatically because it's not throwing new manifests at a new cluster every time. You're taking minor modifications of sets of manifests that work together and basically making tweaks to them as the new deployment happens.
Yeah, and we'll try and show a quick example of that in the demo as well. So this is the validated pattern framework then is an opinionated GitOps stack, but it's not just about the GitOps component itself, right? So OpenShift GitOps leverages Argo under the covers, but I can see there's a number of other capabilities that this framework, we'll call it solves for me.
Yeah. In addition to this, the GitOps mentality is foundational to validated patterns, and there are no validated patterns without the concept of GitOps, as expressed through the OpenShift GitOps operator / Argo CD, also in non-OpenShift environments through Ansible. But GitOps is absolutely central to the validated patterns framework. The idea that we should treat infrastructure and components of solutions in this GitOps way. Additionally, there are things that we recognize that cannot be handled in a fully declarative way. These things, we have imperative hooks that allow us to pick up things that are, kind of ephemeral cluster state. Things like certificates and security tokens and other things like that are relevant to the state of the cluster, but are not things that you can safely handle completely declaratively or store in Git. And because of that, GitOps says that everything should be stored in Git, but we all know that it is not safe to store secrets in Git. If the world were a perfect place, you could just say, look, I'm going to put my secrets in here, but I'm just going to trust you not to look at them. We don't live in that kind of world. So we have to treat secret material specially. And because we have to treat secret material specially, one of the first problems that we realized that we had to buttress in the GitOps framework was by providing a robust and complete secrets handling solution. So within the validated patterns framework, the default way we do that is through HashiCorp Vault and the external secrets operator. But we are very proud of the mechanism that we've made within validated patterns to allow people to store whatever secrets they need and to extract and project whatever secrets they need into their Kubernetes clusters. So this is a very important pragmatic aspect of what you need to do when you're actually dealing with Kubernetes clusters in the real world, as opposed to, just doing demos and things. You need to keep those secrets safe. And then finally, cluster policy enforcement. One of the things that you run into when you're running Kubernetes clusters is that you are probably not just running a single Kubernetes cluster. You have a production cluster, you have a development cluster, you have a testing cluster, and you need to keep these clusters, in some reasonable semblance of, alignment with each other. And so the Validated Patterns Framework provides a mechanism to use Red Hat's Advanced Cluster Manager, or ACM, to keep a group of clusters in sync with each other.
Yeah, I will say that the secrets management component of this was the aha moment for me of starting to work in the Validated Patterns Framework, simply because it is, this chicken and egg problem to always solve of how do I bootstrap, my secrets into an environment, avoiding exactly what you were saying of I don't want to put these things in Git. So I know that was my value as maybe someone as a partner, taking one of these starting architectures that is maintained by Red Hat and being able to build on that. But in conversations that I've had with others, just going back to OpenShift Commons at KubeCon last week, interest from actual end customer practitioners of just having a way, whether it's provisioning one of the existing patterns to try something out that could otherwise be very time consuming a lot of documentation just to get up and running with something, but then even wanting to take that further to use this as the basis of their own GitOps rollouts for clusters and applications. And then probably less relevant for this audience, certainly us on the B2B side, being able to quickly demonstrate a complex stack of infrastructure, or for services partners, being able to create almost the foundation of a practice around a particular solution. I think there's something to be gained for everyone here, and there is. This was just a quick screenshot from the other week of the validatedpatterns.io website. I think there's north of 24 separate patterns on here now. And if you take a second to go browse, it's not, this becomes somewhat more of an infrastructure centric conversation for my part, but there's a lot of interesting patterns on here that get into very specific end user applications, and it really is just abstracting away all of the other infrastructure pain points, things that you would need to solve for. Think about how to automate, removes that component of building out or building towards the infrastructure required to support a very specific application or stack of applications. Anything to add on that, Martin?
Yeah, 24 is about right. We've got more patterns that are in the pipeline. Several are under development right now. And the framework itself is under constant and active development too. We've been working to factor out a lot of the Helm charts that are part of the framework itself, and make it easier to use those Helm charts, either inside the framework or outside the framework as you choose, but also to make it easier within the framework to make, to share patterns, to share those charts amongst patterns. I would also like to highlight that we have a number of patterns here that have been contributed by partners. The Veeam one that we're talking about today is one example. Intel has published a number of patterns as well that are related to their artificial intelligence work. If you go and look through the list of patterns that are available, odds are good that you'll find something interesting. We honestly hope that you do.
Yeah. So with that said, I want to jump into a demo of the pattern that you built that I've then ridden on your coattails, we'll say, to extend that use case. So again, bit of an eye chart here, but sort of the base schematic of the original pattern, which you can still deploy today. That it's called the Ansible Edge GitOps pattern, which the primary components here again become the Argo GitOps controllers on the cluster itself, which are responsible for deploying a number of applications, including the cloud native virtualization or OpenShift virtualization operator, and deploying these VMs. We're deploying an instance of Ansible to do some staging of these virtual machines. And for my part, it really was about, again, just extending that base pattern to include the deployment of Kasten and some additional configuration. And I think rather than look at the slide, it will probably be more illuminating. We're down to about 10 minutes here. Yeah. More illuminating to take a look at the environment itself. So I'm looking at just a single OpenShift cluster here. We'll see if I look at my installed operators. So this started with, again, a completely blank cluster, and I ran a single shell script to kick off the staging for this environment. And roughly an hour later, we can see, again, as Martin mentioned, where we staged OpenShift GitOps to the cluster, as well as ODF. So that's providing my Ceph storage for my VMs, OpenShift virtualization, Ansible, and now we can see Kasten deployed here as well. I've got my group of virtual machines running. We'll look at where that's defined in the pattern in just a second. But that's, this is sort of the end state. It's a boring demo in that, okay, great. I've got VMs running now. I have Kasten already running on this same cluster. I have not touched this environment since just hitting go. But we can see here I've configured a built-in policy for Kasten to effectively back up itself, and then a separate policy for doing backup of my targeted virtual machines. We've configured what we call a location profile. So this is basically the export target for where our backup data is going. So we see that's going to an Amazon S3 environment with immutability protections enabled. And if I went back to my dashboard, I can see that these policies have been running regularly based on those schedules. So all of this came out of, if I swap over to VS Code, all of this came out of this declarative configuration. So at a top level, again, a lot to dig in here that we won't have time for, but the base pattern, allows you to define some set of values that are going to change this configuration. The big pieces here are adding the operator subscription. So because we're deploying from the Red Hat Operator Hub, so we've got the other Red Hat operators for ODF, for OpenShift virtualization, and then we've added the subscription for Veeam Kasten. So if I was using, say, the operator through the Operator Hub where I can transact my Veeam Kasten licensing, that would be a really easy change to make in here. We see the various different imperative jobs that Martin mentioned, so doing sort of those one-off operations. And then applications are going to define all of these different apps that will show up in OpenShift GitOps, in Argo CD, to continually manage the deployment of each of these applications. So we see I've got one here to define one group of virtual machines. I've got one to just deploy Kasten itself, and a separate one to configure Kasten after the fact. And then on the Kasten side of things, so I've got a similar, top level values file that this is a bit choose your own adventure. I chose to abstract certain things that I think would have value for a practitioner here. One of the key benefits of Kasten is we are completely a Kubernetes native application, right? Kasten itself is just a collection of pods on that cluster. So I could see all of the, well, I guess if I look at all instances, to be able to see, all of the various pods, services, et cetera, associated with Kasten, but moreover, all of the resources. So things like our location profiles are defined by just Kubernetes manifests. So this is, in effect, letting me further abstract those Kubernetes manifests if I wanted to provide an even simpler declarative interface for practitioners to, let's say I want to add an additional location profile here. We can do that as maybe a live demo. So I could just make a simple change to this file, and we'll go ahead and just say demo, and we'll commit this. We will commit this change. Oh, I should probably actually add the file first. So we'll commit that change, and we will push that back up to our repository. If I look at what this is going to change in Argo CD, so again, here we see the current sync status of all of those applications that we defined in that values hub file. So I see my deployment of Kasten is happy and healthy. What I want to look at here is my Veeam Kasten config application. So if I refresh this, so it would have eventually detected, hey, we are out of sync because I had made that change. And we see just in that short period of time to say refresh, it has already gone through and added that. So my extra profile that we defined created an additional secret to authenticate for that. So within just a few moments, again, if I come back here and look at profiles, we see that I've got this additional location available to me. So this applies to then anything else that you would do with Kasten within this environment. Again, I've got this abstraction here to be able to add those location profiles. We've got the policy for doing, for Kasten to be able to back up itself. But then if I think about, again, protecting the workload, this is the critical part. Protecting the workload, I need a policy for that application, for that namespace, for that group of resources. And in this case, we're actually maintaining that in this Edge GitOps VMs application. This is what's ultimately defining, what are the VMs that I want added within OpenShift itself. So as I'm creating new virtual machines, I can maintain the definitions of those policies right alongside it. If I need to make changes, let's say I need to extend, how long we retain backups for. This is something that again would follow that exact same GitOps flow. So that was probably a lot to cram into just a few minutes there, but hopefully it gives you an idea of again being able to start with something very simple, pick this. Pick a pattern that is going to help get you much further down the process, and set up to be able to again continuously add your own applications to. Okay, I don't know if I stopped doing the screen share. I'm assuming then folks can see just the slides again, and we're coming up close on time. I don't see anything pressing in the Q&A right now. So I do I do just want to shout out here on the slides. Interesting. That's not updated on my screen. Scott, can you confirm that we can see the OpenShift Commons validated pattern SIG slide right now?
Right now we're seeing the schematic.
Schematic still?
Yeah.
Okay.
There you go.
Oh, there we go. Excellent. So yeah, just a couple of shout outs here. If folks are interested in learning more about how to, I mean, certainly validatedpatterns.io, you can find that data protection for OpenShift Virtualization Pattern or any others, and follow the documentation to deploy that to your own Kubernetes clusters. But if you're interested, certainly in learning more about how to, extend some of these patterns yourself, or have other questions, the Red Hat team has a great live call that they run every other week for the validated patterns special interest group. I wish I had started here. I would encourage other people to start here. So, be willing to read, be willing to ask questions. And Martin and the rest of the folks that work on this platform, incredibly helpful, incredibly insightful. Because again, there's multiple ways to do things, and being able to have that live conversation with the experts and their experiences can really help accelerate things. So definitely encourage folks to check that out. And as always, you can get started with Kasten for free today in any environment. For up to 5 nodes is fully featured. So oftentimes the best way to get started with these things is kicking the tires. So encourage folks to do that as well. Otherwise, Scott, I will turn things back over to you.
Okay. Yeah. Super. Thanks to both of you. There were some audience questions. We'll send those directly to you guys, just so you can follow up with folks individually afterward. But again, Matt and Martin, I just want to thank you for a great presentation today. Really appreciate your time.
Thank you.
Thank you. Yes.
All right, and I'll let those guys go. And our last thing is a prize drawing. And while we do that prize drawing, I do just want to put this this poll up here. Would you like to be contacted by Veeam for more information? So I'll leave that up here. But as far as the Amazon gift card prize drawing, the winner of the $250 Amazon gift card today, just in time for Christmas shopping, is James Meadows from North Carolina. So congratulations to James. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Veeam and Red Hat for making this event possible. And thanks as always for attending. That's going to conclude today's event. Have a fantastic rest of your day.